We are done with chapter number 3, and we're going to look at the review questions. And the first question here, it says, the phases of the moon are caused by its and, okay. So the right answer is spherical shape and orbital motion around the Earth. Of course, the moon is not a cubical in shape. It's spherical in shape. Okay, it's not moving around the sun. It's basically moving around the Earth. But of course, the Earth and the moon as one system is orbiting the sun. 2, waxing crescent moon is visible. And I told you about waxing means increasing and waning means decreasing. And waxing crescent moon is visible near the western horizon just after sunset, as we discussed in the lecture. First quarter moon rises at noon time. You can basically look at the clock, and this is the time where it rises. The moon is visible above western horizon a couple of hours before sunrise. Okay, and this will be waning gibbous. Okay, you know, waxing gibbous is in the night sky, and it will be in the east. So that's one distinction that you basically make between these two. So that's the answer here. 5, the moon moves about eastward in the sky each night. Now remember when we were discussing chapter number 3 and showed you how the face of the moon every night, it's either in the morning sky, or if it's in the evening sky, it's always moving eastward against the stars. So I know that the full revolution is 360 degrees, and the period, one revolution, it's basically 27.32 days. So if you divide that, it will be roughly going you about 13 degrees. So each night, basically, it will be moving about 13 degrees in the sky. The synodic period of the moon, remember we had 2 periods. We had the sidereal, which is 27.32 days, and we have the synodic period, which is 29.53 days. And we said the sidereal is 1 full revolution. Synodic is when we go from a new moon to a new moon. Of course, none of these are basically going to give you anything that it's basically in line with the synodic period. So none of these are basically answers for this. 7, the time for the moon to repeat its cycle of phases is equal to its synodic period. That means either from new moon to new moon, or you're going from full moon to full moon. It's basically equal to the synodic period, which is 29.53 days. 8, when will the full moon be highest above the southern horizon for an observer in the northern hemisphere? And the answer here, it says at midnight near the winter solstice. Now remember when we talked about the full moon, we said the full moon rises around sunset in the east, and it will be at the meridians around midnight, and it will basically set close to sunrise in the west. That's basically the full moon. So it will be at the meridian around midnight. So that's basically, we know where it will be high in the sky. Now, full moon always happens when the moon is opposite to the sun. That means the earth in the middle and the moon basically is facing the sun. That's when you get a full moon. So now, if you are in the northern hemisphere, you know that during the winter, the sun will be at the lowest point south of the ecliptic. So if it is at the lowest point, and when full moon, the moon will be facing the sun, that's exactly where you're going to have the highest point for full moon in the sky. And that's why we have this answer here. 9, a lunar eclipse occurs when the Earth passes between the Earth's moon and the sun. We talked about that. So that's the answer here. 10, during a total lunar eclipse, which of the following are true? Photosphere of the sun is obscured. The moon in the Earth's umbra. That's true. The moon is new. The moon is full. So you know that for the condition for a lunar eclipse, the moon has to be full, and the moon has to be in the umbra of the Earth, which is basically the shadow of the Earth. So the answer here is B. 11, a total eclipse moon glows coppery red because red light is better able to pass completely through the Earth's atmosphere and reach the moon. I told you that the Earth blocks sunlight, and that's why you have the shadow or the umbra of the Earth. But through the atmosphere of the Earth, the light from the sun will be refracted, and red light basically can refract and reach the surface of the moon. And of course, it will give you what we look at as blood moon or coppery red or some of these names. 12, total lunar eclipse always occurs during the time of full moon. 13, during a total lunar eclipse, the moon will glow coppery red. 14, during an annular eclipse, the moon's umbral shadow is too short to produce a total solar eclipse. I told you that for a solar eclipse, it's basically from your location, how big is the shadow of the moon compared to the size of the disk of the sun. And I told you about the motion of the moon around the Earth and the Earth around the sun, and we talked about the different, when the Earth is closer, when the Earth is further, when the moon is closer to the Earth, further than. So actually, when the moon is further from the Earth, then the size will be smaller. That means we say it is too short to produce a solar eclipse, and you get an annular eclipse in that case. And we discussed that in the last lecture. 15, a total lunar eclipse is visible to all observers on the side of the Earth from which the moon would be visible at that time. And I told you this is one difference between a lunar eclipse and a solar eclipse. Lunar eclipse will be visible to all who have night time during the time of the eclipse, but the solar eclipse, only those who basically at the location. And I showed you in the last lecture how that will happen in June the 21st, 2020, and we can look at that to see the solar eclipse. So lunar eclipses are visible to much more people, okay, than solar eclipses. 16, a solar or lunar eclipse will occur when the sun is near the line of nodes of the moon and the moon is new or full. Okay. So basically, these are the conditions. 17, an eclipse season is the period of time during which the sun crosses a node in the moon's orbit. And I told you that the orbit of the moon and the ecliptic, especially it's tilted, the orbit of the moon is tilted at an angle of about 5 degrees. So you may actually have, let's say, sun, moon, earth, which is a new moon, but due to that tilt, the they're not lined up in one line, and you don't have a condition for a eclipse. But when they are near the nodes, that's basically when you have a condition, and we call that an eclipse seasons. 18, if the moon enters the earth shadow but doesn't reach the umbra, the eclipse is termed penumbral. And I told you to look on June 5th, 2020, and that's what we had. We had a penumbral eclipse, so it may look a little bit pink, okay, from here, and that's what I wanted to give you a chance to look at. 19, a solar eclipse occurs when the Earth's moon passes between the Earth and the Sun. That's when you have a solar eclipse. It's basically around a new moon. 20, a total solar eclipse occurred in Wolf Point, Montana on February 26, 1979. When would this eclipse again be visible in Montana? And we talked about the Saros, and we said that's about 18 years, 11 days, and 1/3 of a day. So more or less, the eclipse will repeat itself. But I told you, because of the third of day, it will be at a different location. But in order to get it more or less closer to the same region, you actually want to have one full rotation of the Earth, and that only happens if you multiply the third by 3. So you take the whole Saros, which is 18 years, 11 days, and 1/3 of a day. You multiply that by 3, you get 54 years and 34 days. So if you add this to February 26, 1979, well, 54 to 1979, it will give you 2033. And if you add 34 days to February 26, roughly speaking, okay, if you want to do that, you say February maybe 28 days. So you want to take 2 or 3 days there. Then the rest basically will give you the other month. So, but we have to be careful, because the full moon, okay, only happens, okay, this is not like the solar calendar here. So we'll say within 3 days, depending when basically we will have what we have, a new moon. So that's why we say here, so some maybe you add this precisely, and it should be precisely at that date, but it depends on the phases of the moon. So basically within 3 days of around March 29, 2033. So if some people say, well, you should add, and you get no. Remember, we have to look at the phase, and of course we have this, so we have to say within 3 days here. 21, which of the following is not visible during the totality of a total solar eclipse? Of course, the photosphere of the sun, that's what's not going to be observed. It will be obscured. And this will give you a chance to see the atmosphere of the sun, basically the sphere and the corona. 22, a solar eclipse that occurs when the moon's umbra does not reach the Earth's surface is called an annular solar eclipse. And we already talked about that, okay? The Saros cycle is used in ancient times to predict eclipses. Is 18 years, 11 and 1/3 of a day long. Comes from a Greek word, means repetition. Actually, all of these fit here for the answer. 24, it's the same thing. The Saros cycle is 18 years and 11 and 1/3 day long. 25. The phase of the moon on a particular night is determined by the relative position of the sun, earth, and the moon. 26. On a clear night, when an observer in Los Angeles sees a first quarter moon, an observer in London would see the first quarter moon. It's the same for everyone on the earth. 27. If the moon's orbital plane was aligned with the celestial equator, we would have eclipses only at the equinoxes. Now remember, the eclipses is when you have the sun, moon, and earth in one line. That's a new moon. And if they line up one after the other, then you get a solar eclipse. And if the sun, earth, and moon line up exactly one after the other, and that's when you're going to have what you're going to have a full moon, and that's when you're going to have a lunar eclipse. Okay. And I told you that doesn't happen every month because the orbit of the moon is not basically in the same plane as the ecliptic. They have a 5-degree inclination between both of them. But if they are basically, when they get to the nodes, that's when you have this condition. Now it's a hypothetical situation. You look at the ecliptic, our ecliptic, and you look at the celestial equator, and they intersect with each other, okay, at the time of the spring equinox or autumn equinox. So if, hypothetically speaking, the orbit of the moon is parallel, okay, to the equator or celestial equator, then these will be the nodes. Okay. So the only times that you're going to see eclipses, it will be with the spring equinox or the fall equinox or autumn. 28. Earth doesn't experience a solar eclipse every month because the moon's position is not aligned with the Earth's orbit. And we have that 5-degree inclination. 29. The moon's angular diameter in our sky is measured to be about half a degree. From this, we can find the diameter of the moon if we know the moon's distance. That's geometry. If you draw a triangle, okay, basically if we know the angle and we know how far, you can basically figure out the diameter of the moon. 30. The ecliptic can be defined as the path traced by the sun in our sky over 1 year against the background of stars. Or there is another definition which is not here. It is the actual path of the Earth or the orbit of the Earth around the sun. 31. The lowest amount of solar energy per square meter is incident upon the surface of the Earth in the northern hemisphere on or about December 21st, which is the winter solstice. In our northern hemisphere, that's when we basically receiving the least amount of energy from the sun, because that's where the sun is the lowest point relative to the celestial equator. 32. Full moon always occurs when the moon is directly opposite to the sun. That's when we have when we have a full moon. 33, and that is the last, and this is the last one. In which direction does the daily motion of the moon occur in the sky? We say where, we say toward the east, and we explained that. We had the morning sky and we had the evening sky, and I told you each time the face of the moon moves toward the east, and we already in the question we said it's about 13 degrees every night. Again, We dealt with the review questions in chapter number 1, and we dealt with them in chapter number 2, and now in number 3. The idea of these review questions is you understand why these are the right answers, and it will help you understand the material as well. Any questions on these review questions? So now we're done with them. I wanted to add something here about something that we call a practical Islamic astronomy. And the reason for that, you may go outside and you want to decide on direction of al-Qibla, you want to decide on time for the prayer. Well, you can use what we learned in this course. Okay. So now, when we want to make a calendar, okay, you have basically the yearly cycle or the apparent solar motion with it provides you with unaided timekeeping. That means you're not using it. You're just looking at the sun and you want to basically know the year or the cycle of the year. Now, the division of the solar months and weeks are artificial here. You don't have something that you can tell that this is basically the first week or the second week or the third week, the month, which month. That's basically artificial. So it's not something that very quick that you can decide on. However, when you look at the moon basically, you know that it will go through phases. And you know the first quarter, that means 1 week. Then you know the full moon, that's basically about 2 weeks. And the third, that's about the third. So it will give you an idea, okay, of keeping days in the month. Unlike if you want to rely on the sun to decide what day it is. Okay. So you acquired some knowledge of chapter number 2 and chapter number 3, and you can look at how the sun and the moon are moving, and now we can use them practically for these things. So now, when you look at this calendar, the moon basically can give you a good idea of knowing basically the days of the month, okay, because you can look at the phase that's done. That's, of course, you don't need any aid. And you can look at it, okay. So, and there the Chinese also have their lunar calendar and so on, okay. So in terms of this, the lunar calendar, okay, basically it's practical, okay, and it's combined with other things in the sky. So we have, if you look at the period of the solar year is about 365 days, and every year you add 1 day in order to compensate getting things at the right seasons. And there are differences because we said the orbit of the moon is about 29.53 days, so there is a time difference between the solar and the lunar, about 11 days, okay. But when you look at the lunar year, it may basically become what it you can distinguish what during the month, what day is it of the month. In the solar, that's not as easy as or a quick. So now, how do we basically, for Islamically, how we decide on our months? It's basically always have to be done with the visibility of the new moon. Okay. That means we're going to look at the first crescent of the month, and we decide that this is basically our starting of the month. So the condition when you have a new moon, that's not something that you can see, as we discussed in the chapter. Okay. because the face or the side of the moon that basically receiving sunlight is not seen to you. And we wait till it makes what? It makes a crescent, and you want to look at the waxing crescent, and you decide. And I told you that the waxing crescent will be above the western horizon after sunset. And if you look at the time where the moon is going to rise and set, okay. So for that waxing crescent, it may be visible during daytime, but we cannot see it because the sun is so bright. So you have to wait after sunset to see that. And if the moon sets before sunset, you're not going to see it. So actually you need the moon to set after sunset. If the moon in the waxing crescent sets after sunset and the size is good, you may be able to see the crescent. And if we see that, then we can decide on the beginning of the month. So our months basically in the Islamic calendar or the Hijri calendar, it's either 29 or 30 days, because of the from a new moon to new moon is 29.53 days. So on the night of 29, you try to look and observe the crescent. If you see it, then the next day is the first day of the month. If you do not see it, of course, the next day is 30. You don't have to look for the crescent anymore. And of course, the day after that will be the first day. Now, of course, from our location here, and you want to look at the crescent, the size of the crescent will give you that size of the crescent. How big is relative to us here in order to be seen, which it means how old is the crescent from the time of the new moon at our location close to sunset. So we look at the time of a new moon, and this is now, it's actually known. Okay, you can calculate. Now you look at sunset, closer to sunset at our location here. From that time of a new moon to this time, how much time has elapsed? And we try to look, is it big enough for us to see? It is available during the day, and even if it's during the day, is it old enough that we can see it from here? And there are special cameras that you can see this. And even long time ago, Muslim scientists were basically trying to look at conditions where you will be able to see this. It was done basically by the something that was initiated by the Babylonians, Babylonian, and then it was passed on to Muslims through the Hindus, this kind of knowledge. And you can see here in the cartoon where this is the Babylonians. They were looking and deciding what size should be the crescent and at what angle in order to see this. That means above the horizon. So there were roughly some, we're not going to discuss the geometry of this and the sizes, but what I'm trying to tell you that when you look at the side of the moon that's facing you, how big is this crescent here relative to this, and you decide if it's visible or not visible. So a long time ago, they kind of had conditions how high above the horizon and how basically old to decide if it's something that you can see or you cannot see. So you look here in the slide here, and that's a crescent which is about 28 hours old. That means from the time of a new moon at your location, 50, and it gets larger and larger every night, and of course it's moving toward the east. So that decide on the beginning of the Hijri month, it has to do with the crescent. So you look for a crescent. So if it is 29 of the month, you go out and you try to look for the crescent. Now we know how the Earth is orbiting the Sun, how the Moon is orbiting the Earth, and we can decide precisely the moment when we have a new moon. So at our location here, at sunset time, how old is the Moon? Now there are some rough estimates. If you learn to look at the crescent from here, after sunset, just after sunset, with a telescope, the record time has been observed is when the crescent is about 12 hours old. So if roughly speaking, from the time of a new moon to the time of sunset at your location is 12 hours or more, then with a telescope, you need an aid here. With a telescope, you can observe crescent, provided that the moon sets after sunset. If the moon sets before sunset, you're not going to see that. But if it sets after sunset, then you have a good chance to see it if the skies are clear, of course. So we say it should be above the horizon, and it sets after sunset, and roughly speaking, it should be more than 12 hours old from the time of a new moon. Of course, different locations on the Earth, they will have different times. So it could be seen at one location, and it could be seen another location, because maybe at your location it's only about 10 hours old, and probably it's very close to sunset time where it's going to set. If you go always toward the west, it gets older, and they have a chance to see that. So with a telescope, it's about 12 hours. With the unaided eye, it should be roughly about 15 hours old. If you want to see it with your eye, if it's from the time of a new moon to the time around sunset, if it's about 15 hours at your location, or provided that the moon sets after sunset and the skies are clear and so on, you may able to see the crescent. And of course, if you see it, then the next day is the first day of the lunar month. If not, you continue. Day is 30. You don't have to go on 30, because that's it. The next day will be the first day. Can the crescent be seen during the day? I told you it's too small during the day, and sunlight will not allow you to see that. But now we have special cameras that can basically give you the crescent during the day as well. So now, in our Muslim nations, when we decide on the beginning of the month, we have a clear rule, which basically you have to look at the crescent visibly, and that only the criteria for it is it's going to be toward the end of the month, which basically the 29th day in our Hijri calendar. On that night, you have to go out and observe the crescent. Of course, the crescent of the first crescent of the month, as we discussed on the chapter number 3, it should be above the western horizon. It's not very high, it's very low. And the conditions that we want, it's basically the moon sets after sunset, not before sunset. And it has to be old enough, at least 12 hours old, so you can see it with a telescope to sight the crescent. And we can basically now, there are many programs that you can basically look at. It tells you exactly where the moon is located and the age and so on. And we always go through that. So there are some countries that they decide we're going to decide on the beginning of the month by sighting the crescent with the eye. And I told you the crescent will become bigger as you go west. So countries in the east and the eastern side will actually have less time. And that's why you may have differences. Some countries, they may have, in some areas, maybe the skies are clouded, they don't see. And some places, the skies are clear. So it depends where you're going to decide on this, in which region you're going to basically decide anyone that sees in this region will be applying this. So it depends on either you want to just stick to your location, that means you're only your country, or you can decide with different countries that this will be the whole region, and we'll wait for the other countries to tell us if they sight, so you cannot announce right away after Maghrib time. And we always go through that. Nowadays, they also use the telescope. If you see it with a telescope, then it's fine, okay? Because the telescope basically it's like your glasses. It's not something that basically going to make something appear which is not there. So it's a visual aid. So it is accepted now to see that. So in many countries now, they say, okay, on the night of the 29th, go and look for the crescent. You can use a telescope. You can look with your eye. There are conditions. However, we have astronomical calculations that it can tell us if the crescent is visible or not visible. So if someone says, I have seen a crescent, but the astronomical calculations said no, it's not. You're not going to see crescent with your eye or a telescope. So now it's kind of, they say we're not going to accept that. And that happened this Eid, okay, in May. People actually went outside to look at the crescent, and that was done on the 22nd of May. Now, it was not basically possible to see crescent in our region on the 22nd of May. And that's why 23rd was Ramadan 30, and of course Eid was on the 24th. Some African countries, I think they said they witnessed a crescent, but it wasn't the one that's for the moon. It's basically from Venus, and we'll talk about this maybe in chapter number 4. So Venus, if you look at it with the telescope, it may give you crescents. And also it is in the west, in the western horizon where the location, so it could basically fool people sometimes. Now, some other nation basically based on calculation, they say if the crescent is possible, they use calculation. It is possible to sight a crescent on that night, then that's it. The next day is the first day. They don't basically go out and sight the crescent, but they will decide on that. In some countries, they go with the new moon. They look at the condition where there is a new moon. If the new moon happens, let's say this criteria was used in Libya in the days of Gaddafi. When they looked, if the new moon happened even a minute before sunrise on the furthest eastern point in the country, so they say it happened before the day begins. So they say it happened in the night before. They say, well, the moon will be basically now moving from a new moon, which making a crescent. and this crescent will become bigger and bigger. It may not be possible to see crescent at our location. It's small. However, there will be another location further from us where they will be basically have condition where they can sight a crescent. So they take the time of this new moon. If this new moon, which we call a new moon in English, or we call it conjuncture بالعربي نقول لحظة اقتران أو المحاق أو القمر الجديد. So they take that point. If that point happened at least before sunrise, then they say the next day is going to be the first day, and that's it. I think Libya, Nigeria were using this. In some other countries, they look at astronomical calculation and they say, well, it has to be when we have the sighting of the crescent is possible on that night. And of course, countries that stick to saying that we have to witness a crescent visibly. And there are now some are using some cameras to look at the crescent even during the day. But I don't think this has been adopted yet. And that's why you have these differences. And I always say, Al-Amr huwa Amr ta'abbudi. So from my own point of view, don't try to make too much out of this. If one country announces, the other country doesn't announce, they all can say, well, in my location, the crescent is not visible. Okay. Well, it was a cloud. So I would say it is something of but now astronomy can tell you if it was possible to see that or not. So this year here for our Eid, some people actually announced that on the 22nd they sighted a crescent. A long time ago, maybe that was accepted, but now they told them no, it is not. It's not possible to sight crescent on the 22nd. So, and you can use calculations and so on. So we decide, for example, if this is very clear to you, you look at this one here, it's very faint. So it's not easy to sight a crescent of the beginning of the month. As you can see from this slide here, you really have to go somewhere where you have a clear skies to see that. Okay. And no clouds and so on. So it's not you're basically trying to look at the crescent from your home, and you have too many city lights and so on. And if the time for moon setting is very short, and the moon is, you really need to go somewhere where it is possible to see this. So usually now in astronomy, we look for the time of a new moon, which we call conjuncture, or we call it iqtiran, or we call it mahaq, or qamar al-jadid. We know this time now. There are many programs that they tell you this time. And now at sunset, at your location, how old is the crescent? Is it old enough? And you can also know its location. So how high it is above your horizon. It is something that you can see or you cannot see. And the time between moonset and sunset. If the moon sets before sunset, that you're not going to see that. If the moon sets after sunset, how much time? So it will give you conditions. Of course, there are conditions that you cannot control, like a humidity, dust, light, pollution, and many of these things. That's something that occur in your sky, but you may have different cities or localities close to you that can give you that, and you can look at this. Now, I'm talking about, we're very soon going into Eid al-Adha, and we decide that in Dhul Hijjah, the first of Dhul Hijjah. Okay. And later on, I will show you the program called Accurate Times. And this program basically can give you a map, okay, to see where it is possible to sight a crescent. And you see colors here. Red color, of course, you cannot sight the crescent. So if I look at here, it says red light, impossible. You cannot see anything. No color, not possible to see that. No color, that means white. It's not possible to see that. Blue, need optical aid. So with the blue color, that means you need a telescope to see that. Magenta could be seen by the unaided eye. Of course, green, it will be visible. So if you look at this map here, on July 20th, 2020, and you want to go out and look for a crescent, of course, all these region here in red, it's impossible to see crescent on that night. But in this region here, it's not possible. If you want to see it, it will be possible here with a telescope. But of course, we don't share the night time and so on with this region. Now, if we look at July 21st, and July 21st, okay, in this region here, it will be very clear because it's a green now. In this region here, it will be possible to sight with the unaided eye. And here, of course, they need what they need, an optical telescope. Now, someone will say, how come? These are different regions. So this is around, and remember, the crescent of the beginning of the month is above the western horizon at any location, and it's only around sunset time. So these have different times. Okay, that doesn't mean they're looking at the same time. Okay, there is a big difference in time between these regions. But Maghreb here is not at the same time here. It's not the same time here. That's why it's a green here. So on July 21st, you can sight what? You can sight a crescent. So if July 21st happens to be 29, then July 22nd will be the first day in the month for us, which will be first of the Hijjah. If this happens to be July 21st, day 30, then of course the 22nd will be the first day. So from this, it looks like that July 22nd is the first day of Dhul Hijjah. So 22nd, if you count in your fingers, 22nd, 23rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. So most likely, July, if you count from here, so 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So it looks like that Eid al-Adha might be on July 30th from here. So that basically gives you an idea of how can you decide on this. I will try to share probably this application with you, which is called Accurate Times. Okay. And this program, there are, I think, other programs, but so if you actually download this, okay, it's from the International Astronomical Center. Okay. And when basically you'll see it, it gives you something like this where you put your references, location, date. Okay. Now it will give you prayers times, moon phases, crescent visibility, and at Qibla direction. You can basically click at any one of these, but of course you have to set your location. So for example, if I want to go to crescent visibility, and then I want to look at the year 1441, which I have here, and I want to look at Dhul Hijjah, okay. You have to press on preview, and then you'll go to a crescent map, and it will give you July 20th here, for example. You can say draw, and it gives you the map that we looked at, and that's the one that I presented to you, and it tells you if it's possible or not possible. So it looks like on July 20th, you cannot basically see any of these. But if you look at July 21st and you draw, and it will give you the map that you can see. Of course, there are some differences in the criteria. You can look at here, there is Ouda and there is Yolov. So you can use different things, but more or less with astronomy, we know how the moon orbits the Earth, and we know how the Earth is orbiting the sun, and we can look at different location and how the relative positions are, and you can decide basically on the beginning of the month. Okay, now you can look, for example, at moon times. Okay, and this now, I don't know if you're seeing this, but it will give you the time in this day, the time, the rise of the time, the set of the time. So you can look at these. The same thing, moon phases, and you can calculate. Okay, and it will give you the time for the new moon, first quarter, and so on. So for example, in July the 3rd of June, we had a new, that's 2019. So you may have to basically go and change the time here. So we change this year to 2020, and you click on it, and it gives you the times. That's why on May 22nd, it was a new moon at around 9:39 p.m. in our location, and that's why it was not possible to sight a crescent. On June 21st, that's when we have a new moon, and that's why I told you that we can see probably a solar eclipse in our region. On July 20th at 9 p.m. at our location here, we have a new moon. So it's not possible. The new moon also comes way after sun set and that night, so we cannot see what we cannot see a crescent and that night. So that's basically, you can use this program to do this, okay, for you. And you can decide on the beginning of the month, the Hijri month, and so on. So you can basically just use the criteria that long time ago they used. That means you have to look for in the west, above the western horizon, things like. But now it is calculated, and it is known where the moon is, and even it could be sighted during the day if you want to use the special camera and so on. Now, the other thing that you can use basically to decide on the direction of the Qibla, okay, where is the Qibla for you? Practically speaking, we know how the sun is moving. I told you that the sun basically comes from the east and it goes toward the west, but it does that with this trajectory here. So now if you want to look at the shadow, well, the shadow when the sun is here, it will be in the north, because I told you this is the south. I told you if you face north, you're not going to see the sun. You have to face south, and of course it will come from the east, it will go to the west, and it will follow this trajectory here. And you can kill direction if you look at the shadow here. If it's in the north, that means you are at the highest point, which is the meridian. Okay. If you're in the morning, the shadow will be in this direction here. And of course, if it's here, the shadow will be, if you're in this location here, the shadow will be in the east. So from this, you can basically look at the shadow and decide the direction. And now you can basically decide where I'm located relative to, let's say, Mecca. Okay. And if you decide where are you relative to Mecca, okay. So for example, if someone is in Paris, okay, and Paris is northwest from Mecca. So if they want to face Al-Qibla, they have to look southeast on their direction. And they can use, I showed you, the sun, where the shadow of the sun is, to decide on that direction. So they can find the direction of what the direction of Qibla. So if we look at the sun here, we say that the shadow direction toward the west in the early morning hours, northwest before noon time. Noon time it will be north, as I showed you. Northeast midday, and of course it will be the east after noon time. And late in the afternoon, it will be where it will be in the east. So you decide where your direction is. And if you know where your direction is relative to Mecca, you can basically look at the shadow here, and you can basically decide which way you're going to face to Al-Qibla, roughly. Okay, in the program that I just showed you, you can basically look at the calculation. It's done relative to the north, true north or geographic north, and you can basically look at that. And you decide what you decide on the direction of Al-Qibla, which is something practical. At night, you can look at the moon as well, or you can look at the skies to know where the directions are. And you can also decide. That, of course, takes a bit of skill, but you can basically develop this based on what we learned in this. Now, in terms of the time of the prayer, you know that in Fajr time, when days break, okay, indirect sunlight, which is twilight, you look at, and that will be the direction of the east. Dhuhr, when it's basically crossing the meridian, the highest point. Sometimes نحن بالعربي نقولوا له وقت الزوال. لو الشمس عمودية at your zenith, then there will be no shadow, and we say this is zawal al-dhul, and that's the time for what? The time for Dhuhr. However, the sun could not be always on top of your head, but we look for the shortest shadow. When you basically have the shortest shadow at your location, that's the time for Dhuhr. And when the shadow is equal to the length of whatever you're trying to look at the shadow, that's basically Asr time. And Maghrib basically begins, you know, when the sun is basically sets. Isha will be indirect now of sunlight. That's the start of the evening astronomical twilight. That means stars will become a little bit visible. I think 2-3 years ago, the time was set at around 1 hour and a half. So if you look at, I think 3-4 years ago, when you look at your timetable, you'll always find that between Maghrib and Isha, it's about 1 hour and a half. Now it's different. They actually start using astronomical calculation, and it will vary, but it's more than 1 hour, 1 hour and 10, 1 hour 15, and so on. That's the difference between Isha and Maghrib. So with the knowledge that you learned in chapter number 2 and 3, at anywhere that you're located, you can basically find out the direction of Qibla by looking at the sky. You can basically look at the sun and decide on the time of prayer's time, okay, what time it should be. And now you have a good idea of how we look at the beginning of the month when we basically look at the crescent. But as I told you, you can basically look at this program, which is called Accurate Times. And I think the organization is here in United Arab Emirates. And you can use that to learn, okay, of the accurate times, okay, when the month is going to start. So, for example, this year, when we looked at Eid, I told you in some countries, they basically found out that, well, on the 22nd of May, they observed a crescent. But it wasn't the crescent of the moon. And you actually get some people swearing that they use the telescope and they have seen a crescent. But it's not the crescent of the moon. Probably some time ago it would have been taken. Their witness, it could be considered. But now we know. I mean, there are many Muslim astronomers now, and they can decide. So you may have differences between countries, but they all have a logical reason to say why we're starting Eid or Ramadan in the next day. They may say, well, at our location, okay, it's not possible to see this because they are in the east. The country next to them, they also cannot see it, but the country next to them, they may actually say it's not just our own country. We look at other 3 countries west of us. We consider ourselves as one locality, so we wait for them. And you may actually have the announcement after Isha because they have to wait. Sometimes it's not visible here in United Arab Emirates, but it's visible in Saudi Arabia, or sometimes it's visible in South Africa. And if you have, because of the astronomy now, they tell you where it's visible. If you send people to South Africa and they witness the crescent there and they tell you, we almost have the same time, so it's okay. So from my point of view, that's my point of view. Okay. You understand now, don't make too much out of this. If they want to start on that day, the next day, I told you there is, but at the end of the day, it is basically Amr Ta'abbud. It's up to them. And as I told you, in each one can use this. I basically, so is this clear? Any question on this?